So hello everyone, I hope you are doing well. Welcome to the Python Programming Fundamentals course. My name is Bharat and I will be guiding you through this course over the coming lectures. We will start from the absolute basics of programming and gradually move towards writing real Python programs. Now, before we begin, let me ask you one simple question. How many of you use smartphone every day? I'm sure almost everyone does. Every day, we use applications like WhatsApp, YouTube, Instagram, Google Maps, Amazon, Flipkart, online banking, UPI banks, food or delivery apps, and many more. Have you ever wondered who created all these apps? Did they appear automatically? No. They're behind every application, every website, every game, every ATM machine. There are programmers who wrote thousands of millions of lines of code. Today, we will begin learning the skill that makes all technologies possible, which is programming. So, these will be the topics which we will be discussing in today's lecture. These are what is programming, algorithms, flowchart, pseudocode, and programming in Python, compiler versus interpreter, and then at last why Python. So, why first we have to learn programming? Some students think programming is only for computer science students. That isn't true anymore. Today, programming is used in almost every field. For example, banks use programming to process millions of transactions. Hospitals use software to maintain patent records. Airlines use software for ticket booking and flight scheduling. Online shopping websites use programming to recommend products. Even traffic signals, smartwatches, and washing machines contain software written by these programmers. Wherever you see technology, there is programming behind it. Learning programming does not teach you how to write code. It teaches you how to think logically, break down problems, and build solutions. This is one of the most valuable skills you can develop. So, what's today's topic? So, let's see what we will cover in today's lecture. Today's is an introductory lecture. So, before writing our first Python program, we need to understand some important concepts that every programmer should know. So, today's topic include what is programming, programming process, algorithm, flowchart, pseudocode, programming languages, interpreter and compiler, why Python is so popular. Finally, we will write our first Python program, the famous Hello World program. By the end of today's class, you will not just know what Python is, you will understand how programmers think before they even start writing code. So, what exactly is programming? Let's start with another simple question. Imagine your mother asks you to make a cup of tea. Would you simply stand there looking at the ingredients? Of course not. You will follow a sequence of steps. Like first you will boil the water, then add a tea powder, then add sugar, then at last milk. Finally pour the tea into the teacup. If you skip one of these steps or perform them in the wrong order, the tea won't turn out correctly. Programming works in exactly the same way. A computer does not know what you want. It doesn't think. It doesn't guess. It doesn't make decisions like humans. Instead, it follows only the instructions that we give it one step at a time. Programming is the process of writing these instructions so that the computer can perform a specific task or solve a particular problem. So what is a computer? So before we are going further, remember one important fact. A computer is a very powerful electronic machine, but it has only one limitation. It can't think on its own. So if you ask a calculator what is 5 plus 5, it immediately gives the answer. But if you ask what should I eat for dinner, can a calculator answer? No, because calculator only understands the operation it had been programmed to perform. Similarly, every computer follows the instructions given by the programmers. These instructions are written using programming languages such as Python, C, C++, and Java. So consider this real life example. Let's look at some examples around us. Like when you consider calculator, when you press 2 plus 3 equal to, the calculator displays 5. Did it magically know mathematics? No. A programmer wrote instructions telling it how to perform. addition. And let's consider ATM machine. When you insert your ATM card and enter your PIN, the machine verifies your details and checks your balance and dispenses cash. All these operations happen because programmers wrote the software controlling the ATM. Consider WhatsApp. When you send a message to a friend, it reaches them within seconds. That entire process, sending, receiving, storing messages, showing notifications, is controlled by programmers. Also, the applications like YouTube, suppose you watch videos about Python. After some times, YouTube starts recommending more Python videos. If someone sitting inside Python manually selecting videos for you, of course no, right? The programming and algorithms analyze your interests and automatically recommend the similar content. So, what are the key points to remember from what is programming? So whenever someone asks what is programming, you always should remember these simple ideas. Programming is about solving problems. A problem is a collection of instructions. A computer follows instructions exactly as written. A better thinking leads to better programs. So now I would like to ask all of you a question. Can anyone name one application that you use daily which is built using programming? Excellent. Whether it's Instagram, Google Maps, Spotify, ChatGPT, Netflix, a simple calculator, every one of them exists because programmers wrote software for them. Now we know what programming is. But before writing any problem, do programmers immediately start coding? No. Professional programmers first follow a proper sequence of steps to solve a program. This sequence is called the programming process. Let's understand in our next topic. So now that we understood what programming is, let's move to our next topic, the programming process. Many beginners think programming means opening VS Code and immediately writing code, but professional programmers don't work like that. Before writing even a single line of code, they first understand the problem, plan the solution, and only then start programming. This systematic approach is called programming practice. Today's slides shows 5 important steps: problem, algorithm, program, computer, and then at last output. Let's understand each one of them. Step 1. Problem. Every program starts with a problem. If there is no problem to solve, there is no need for programming. For example, suppose your teacher asks you to calculate average marks of the student. That's your problem. Or suppose a bank wants a software to transfer money securely. That's also a problem. Every food delivery apps solve problems by helping customers order from food from home. So the first question every programmer asks is, what problem I am trying to solve? Unless the problem is clearly understood, writing code becomes very difficult. What's the step 2? It's algorithm. Once we understand problem, we don't immediately start coding. Instead, we prepare a solution step by step. That step-by-step plan is called algorithm. Think about traveling from your college to your hostel. Do you randomly start walking? No, you already know the route. Similarly, before writing a program, programmers first decide the sequence of steps needed to solve a problem. The algorithm acts as the blueprint of the program. As an architect prepares a building plan before construction begins, programmers prepare an algorithm before writing code. Step 3. Program. After preparing the algorithm, we convert it into a programming language. It's called the program. The algorithm itself cannot be understood by a computer. So we write it in a computer languages like Python, C, C++, Java. Today, we will learn Python. So most of our programs throughout this course will be written in Python. So step 4, computer. Once the program is written, we will give it to the computer for execution. Now remember something very important. The computer does really exactly what we tell it to do. It never assumes anything. It never corrects our mistakes automatically. If our instructions are correct, the computer produces the correct result. If our instructions are wrong, the computer will also produce the wrong result. That's why programmers spend so much time planning before coding. Step 5. Output. Finally, after executing the problem, the computer gives us the output. For example, suppose the program is to calculate an average marks of a student. Input like English equal to 80, Maths equal to 90, Science equal to 100. The program processes these values. Finally, the computer displays average equal to 90. This displayed result is called output. So let's understand complete programming process with one simple example. So suppose your teacher asks you to calculate the area of rectangle. Step 1, the problem. Calculate the area of rectangle. Then read its length, breadth, height. Multiply a length and breadth. Display the area. So the step 3, program. Write these steps in Python. Step 4, computer. The computer executes the Python program. Step 5, the computer displays the calculated area. Can you see how every steps depend on previous ones? Without understanding the problem, we can't create the algorithm. Without algorithm, writing program becomes confusing. Without program, computer cannot execute anything. So without execution, there is no output. So that's why every program always follows a sequence. So let me ask you a question. Suppose I directly start writing code without understanding the problem. Do you think I always get the correct answer? Exactly, probably not. Because writing code without understanding the problem is like building a house without a blueprint. So it wastes time and usually leads to mistakes. So there are some key points to remember from this topic. Like before we move ahead, remember these 5 steps. Problem, what needs to be solved. Algorithm, the plan of the solution. Problem, program, writing the code. Computer, execute the problem. Output, get the final results. If you remember these 5 steps, you are understood the programming practice. So now we have seen the algorithm is one of the most important steps in programming. What exactly is an algorithm? How do programmers write one? Let's understand that in our next topic, which is algorithm. Now let's move to the one of most important concepts in programming called algorithm. You have just seen that in the programming process, the second step is created an algorithm. An algorithm is a step-by-step procedure to solve a problem or a complete task. Notice something important. Algorithm is not written in Python, C, or Java. It simply describes how a problem should be solved. It focuses on logic, not the programming language. So, real life example. Let's understand with a simple example. Suppose your mother asks you to prepare a sandwich. Do you randomly throw all the ingredients together? Probably not. You follow a sequence. So, take 2 slices of bread, apply butter, add vegetables, add cheese, close the sandwich, and then you will serve it. So it means if you miss a single step or perform them in a wrong order, sandwich may not be prepared correctly. These order steps form an algorithm. Another example. Imagine you are using Google Maps. When you enter a destination, does Google magically show the route? No, it follows a series of logical steps. It checks your current location, it finds all the possible routes, it calculates the shortest or fastest route, then it displays direction. That entire process is based on the algorithms. Every navigation app, every search engine, every social media platform uses algorithms. So now the question is, can we write any random, can we write any random steps and call it an algorithm? No, a good algorithm should have a certain characteristics. These characteristics are its algorithm supposed to be clear. Every step should be easy to understand. There should be no confusion. For an example, cook the food. It is very unclear. Instead, boil water for 5 minutes will be an instruction is precise. The computer requires in this level of clarity. Second one, simple. A good algorithm should avoid unnecessary complexity. Suppose there are two ways to solve a problem. One requires 10 steps, the other requires 5. Which one would you choose? Obviously, the simpler one. Simple algorithms are easy to understand and maintain. Third one, the algorithms always produce the correct result. Imagine writing an algorithm for addition. If 5 plus 7 gives 20, is that algorithm correct? Of course not. No matter who executes it, the results should be always be correct. Step 5. Efficient. Efficiency means less time and fewer resources. Suppose you have to find one student name in a class. One method is to check every student by one on another. Another method is uses the roll number directly, which is faster. Second one, programmers always try to design efficient algorithms because efficient software runs faster. Fifth one, find it. Finally, every algorithm must end. It should never continue forever. Imagine asking someone to study endlessly without stopping. Would the task ever finish? No, actually. Similarly, every algorithm must have a proper starting point, and that's why we have a good algorithm. It's finite. So let's write an algorithm for a simple problem. The problem, find sum of two numbers. So what's the algorithm? First, we have to start the algorithm. Read first two numbers. I mean, read the first number, then read the second number, add both the number, then display the result, and then stop the program. Notice something. Have we written any Python code? No. We have simply described the logic sequence. Later, these same steps can be converted into the programming languages respectively like Python, C, Java, or any other programming languages. That's why an algorithm is said to be independent of programming languages. Okay, so what are the advantages of algorithm? So why do programmers spend writing algorithms time? There are several benefits. First, an algorithm is easy to understand because they use simple language. Second, they help us plan the solution before writing code. Third, if there is a logical mistake, it much easier to identify it in the algorithm than after writing hundreds of lines of code. Finally, the same algorithm can be implemented in different programming languages before without changing its logic. So let me ask you a question. Suppose I ask you to calculate an average of 5 students. Would it be easier to directly start coding, or would it be better to first write the steps on paper? Exactly. Writing steps first help us think clearly and reduces mistake. That's the main principal purpose of algorithm. So far, we have learned how to represent a solution with written steps. But sometimes written steps are difficult to understand, especially in large programs. Wouldn't it be easier if we could draw the logic instead? That's exactly our next topic is. Now we will learn flowcharts, which represent algorithms using standard symbols and arrows instead of plain text. Now we have learned how to write an algorithm using simple English steps. Let's look another way of representing a solution. Sometimes, when a problem becomes large, reading long lists of steps can be confusing. So, let's instead of writing another and everything in words, wouldn't be easier if we could draw the solution. So that's exactly what flowchart is. Flowchart is a graphical or pictorial representation of a algorithm. Instead of writing sentences, it uses standard symbols connected by arrows to show the flow of problem from beginning to the end. So why do we use flowcharts? Imagine we receive two sets of instructions. First is full page of text explaining how to assemble a bicycle. Second is a diagram with arrows and pictures showing each step. Which one would you understand more quickly? Most people would choose the diagram. That's because our brains process visual and information much faster than the long paragraphs. Similarly, programmers use flowcharts to understand the program logic before writing code. Flowcharts make easier to identify mistakes, explain ideas to others, and plan complex problems. One of the best things flowchart is that they use standard symbols. No matter where you work, study, or work. These symbols remain the same. Let's understand the important ones shown in your PPT. Symbols like start or end will be at oval shape. The rectangle represents a process or an action. So whenever a computer performs a calculation or executes an instruction, we use rectangle. Examples include add two numbers, calculate average, find area, multiply values. Whenever your work is being done, think of a rectangle. Input or output symbol, which is parallelogram. A parallelogram is used whenever the program receives input or displays count. For an example, let's consider input. Let it be enter your name, then enter marks. After that, enter age. What will be the output? Display total. Consider display the results to print hello. So wherever the data enters or leaves the computer, we use parallelogram. So this is simple. A diamond represents a symbol. This is where the computer asks you a question. For an example, is age greater than 18? Is the password correct? Is the number even? The answer is usually yes or no, or true or false. Depending on the answer, the program follows a different path. That's why a diamond usually have two arrows coming out of it. Let's that's why finally arrows connect all the symbols. These arrows show the direction in which a program should move. Without arrows, we wouldn't know which steps comes next. They guide us from start to end in the correct sequence. Let's consider how I have given you a simple flowchart example. What does it do? It adds two numbers. The flowchart would be start, then input number one and number two, then add the numbers, then display the sum, and then end the program. Even without writing a Python code, we can clearly understand the logic behind it. So, what are the advantages of flowchart? So, why do programmers use flowchart? There are many advantages. They are easy to understand because they use diagrams. They help in planning before coding. They make debugging easier by showing the program so flow easily, clearly. They improve communication among team members. They act as documentation for future references, especially in the large software projects. Flowcharts save a lot of time because everyone can understand the logic without reading code. So now we might think if both flowcharts and algorithms display the solution, what's the difference? Let's have a simple comparison. Algorithm written using words, and they are easier to write and this for simple programs, whereas flowchart drawn using symbols, easier to visualize, best for understanding complex logic, but both describe the same solution. So only difference is they are how they are presented. So let's do a quick activity. Suppose I ask you to write the steps for withdrawing money from ATM. Can you think this sequence? Maybe you start like start, insert card, enter your PIN, verify PIN, select withdrawal, enter amount, dispense cash, end. Now imagine drawing these steps using clear chart symbols. Wouldn't it be much easier to understand? That's why programmers love using flowcharts. So before we move ahead, let's remember these important points. A flowchart is a graphical representation of an algorithm. It uses standard symbols while arrows indicate the direction of execution. It makes the program logic easy to understand, create before coding begins. So, as we have learned two ways of reference a solution, algorithms and flowcharts, there is one popular method that combines the simplicity of English with the structure of programming. That is called pseudocode. Let's learn about pseudocode in the next topic. So far, we have learned two ways of represent the solution to a problem. First is an algorithm where we write entire code in steps like simple English. The second is a flowchart where we represent those steps in diagrams and symbols. Now let's learn the third method that programmers commonly use before writing the actual code. That method is called pseudocode. So what pseudo means? The word pseudo means false or not real. So pseudocode means, yeah, the code that looks like programming code but actually an actual programming language. Simple words, pseudocode is the way of writing logic of a program using plain English mixed with programming style keywords. It helps programmers focus on the solution without worrying about the rules or syntax of a programming language. So, may I ask a question? Why do we need a pseudocode? Imagine you have a great idea of solving a problem, but you haven't learned Python yet. Can you still explain the solution? Of course, you can write the steps in simple English. Now, imagine another situation. You have learned some programming concepts and you want to write your solutions in a little more structured way. Instead of writing long English sentence, you write something like start, input number, process the data, display result, and then stop. This is a pseudocode. It's easier to read than actual code and much easier to convert into a programming language later. So I have given you an example. Let's solve that in let's decode it and let's understand it well. The pseudocode looks like this. First we are starting the pseudocode, input first number, then input second number, and then we are giving say sum. So first number plus second number, then display sum. After that we are stopping the program. Notice something important. This is not the Python code. There are no brackets, no columns, no special syntax. Anyone, even who has never learned programming, can understand these steps. This is the biggest advantage of pseudocode. So, a good pseudocode should always have several important characteristics like it's supposed to be easy to read and it should be language independent, focus on logic, easy to convert. Okay, so these are the basic characteristics a pseudocode supposed to be having. So first, let's understand the difference between algorithm and pseudocode. Students often get confused between these two things. So let's compare them. Algorithm, it's a written in completely in simple English. Every steps are described in the plain English. Very easy for beginners. Pseudocode looks similar to the programming code. Uses words like start, input, display, stop. Easier to convert into an actual problem. Both describe the same logic, even though, but the only difference is the style in which they are written. So, why do programmers use pseudocode? So, there are several reasons, and these are the advantages of it. By the way, it helps organize thoughts before coding. It is easier to understand than the actual source code. It reduces the programming mistakes. It improves communication among team members. It makes converting idea into code much faster. Instead of worrying about Python syntax, programmers must make sure that logic is correct. Suppose I ask you to write a program to calculate average marks of three students. Don't write the Python code. Instead, think in a pseudocode way. You may write something like start, input 3 marks, calculate the average, display the average, stop. See how simple is it? Once these steps are correct, writing the Python program becomes much easier. So before we move to the next topic, remember these important points. Pseudocode is not a programming language, it's a false one. It uses simple English with programming style keywords. Focus on logic rather than syntax. It is easier to convert into actual code. It helps programmers plan before coding. And till now, we have learned three ways to represent a solution. Algorithm, which is written steps, flowchart, graphical representation, pseudocode, structured English. Now we know how to plan a solution. Now the next question is how do we communicate these instructions to a computer? For that, we need programming languages. So let's move to the next topic, which is programming languages. Now we have learned how to plan a solution using algorithms, flowcharts, and pseudocode. But there is one problem. Can a computer understand English? Can it understand flowcharts? Can it understand pseudocodes? Of course, the answer is no. A computer understands only machine language, which is consists of zeros and ones. Sim- since humans cannot write these kind of programs using ones and zeros, a special languages were developed to communicate with computers. These are called programming languages. So, what are these programming languages? A programming language is a language used by programmers to write instructions that a computer can execute. It acts as a bridge between humans and computers. We write instructions in a language we understand. Later, those instructions are converted into machine languages so that the computer can execute them. So, imagine you are traveling to Japan, but you know only English. A locust person speaks only Japanese. So, how can you both communicate easily? Probably can't. Both of them won't understand the respective languages. So here you need a translator. Similarly, humans understand English. Computer understands binary, which is zeros and ones. A programming language acts like a translator between humans and computers. So there are some examples of programming languages, like proper examples such as C, C++, Java, Python, JavaScript, C has. These languages has its own strengths and it's used for different types of applications. In this course, we will focus on Python, one of the most beginner-friendly and wide-used programming languages today. So, what are the types of programming languages? So, the Python programming language can be broadly classified into three ones called machine language, assembly language, and high-level language. So, in that, there is one thing called low level languages and another thing called high level languages. So, what are the low level languages? Low level languages are very close to the machine language. They are fast because the computer understands them easily. However, they are difficult for humans to read and write. Examples include machine language, assembly language. These languages are mainly used where maximum preference or hardware control is required. So the next type of programming languages are called high-level languages, which are much closest to the human languages. They are easier to learn, easier to write, and easier to debug. Examples include Python, Java, C++. Most software applications we use today in this digital era are developed using high-level languages because they improve programmers' productivity. So let me ask you a simple question. If I ask you to choose between writing thousands of zeros and ones or writing simple Python statement like print hello, which would you choose? Obviously Python. That's why high level languages become so popular. So here is an interesting question. If computers understand only binary languages like zeros and ones, then how does a Python program actually run on a computer? Who converts our Python program into machine language? The answer lies in two important programs like compiler and the interpreter. So let's understand them well. In the previous topic, we learned that computers understand only machine languages, which consist of zeros and ones. But we write programs in languages like Python, C, or Java. So here is the important question. How does computer understands your program? The answer is through compiler. A compiler is a software program that translates the entire source code written in a programming languages into machine code before the program is executed. So the real life analogy. Imagine you are writing a book in English. Now you want people in France to read it. Instead of translating one page every day, Your translator converts the entire book into the French first. Only after complete translation is finished, people do start reading it. A compiler works exactly the same way. It first translates the entire program and then allows to run. So how does a compiler work? So compilers follow these three steps importantly. So they read the source code, they convert the entire source code into machine language. If there is no errors, generate an executable program. Only after successful compilation does the program run. So if even one major error exists, the compiler reports it and the program will not execute until the error is fixed. So there are some advantages of compiler. So first of all, why the compilers are useful. So the final program runs very fast because it's already translated. Errors are detected before execution. The compiled program can be executed multiple times without recompiling unless the source code changes. That's why languages like C, C++ commonly use compilers. Suppose you have written 100 lines of C++ code. The compiler reads all the 1,000 lines and converts them into the machine language and then creates an executable file. Only after this process is complete can you run the program. So unlike the compiler, this translator does not wait the entire program to finish. Instead, it translates the executed program one by line at the time. This is called an interpreter. So an interpreter is another type of language translator, but unlike a compiler, it reads, translates, executes one statement at a time. So imagine you are attending an international conference. A speaker talks in Japanese. An interpreter stands beside the speaker. Speaker says one sentence. The interpreter immediately translates that into English. Then the speaker continues with the next sentence. The process repeats throughout the speech. The interpreter never waits until the speech is over. Similarly, a Python interpreter executes program line by line. So how does an interpreter work? So it process very simple. It reads one line, translates it, executes it immediately, move to the next line. If an error occurs, the execution stops at that point. That means that the remaining lines are not executed until the error is corrected. So what are the advantages of interpreter? So there are some advantages like it's easy to test programs. Errors are found immediately, excellent for beginners, and useful during development and debugging. This is one of the reasons why Python is considered user-friendly. So I have discussed about the applications of interpreter. Like each, we can use it for self sandboxing, visualization, self-modifying, emulator. Like many, there are many. But now let's see the difference between compiler and interpreter. A compiler translates the entire program at once, whereas the interpreter translates one line at a time. Compiler creates an executable file, whereas interpreter does not create a separate executable one. The execution is usually faster in compiler, whereas it's comparatively slower in interpreter. Errors are shown after compilation for compilers. Errors are shown immediately during executions, which, which is for interpreter. So these are the major difference between both compilers and interpreter. Neither is better than the other. Each has its own purpose. The languages like C, C++ generally use compilers, while Python uses an interpreter. That makes Python much easier to learn, experiment with, and especially for beginners. Suppose you have written a Python program with 20 lines. If there is an error on the 8th line, what will happen? Yes, the interpreter will execute the first 7 lines successfully, then reach to the line 8. It will report the error and then stop. Once That's one of the key difference between an interpreter and the compiler. Now we know how problems are translated into machine language. The next question is, why are we learning Python instead of some other programming languages? Let's understand why Python is one of the most popular programming language in the world. Now we have reached one of the most important questions of today's lecture. There are hundreds of programming languages available. Languages like C, C++, Java, and many others are widely used. So why are we learning Python? So why has Python become one of the most popular programming languages in the world? Let's find out. What is Python? Python is a high-level, interpreted, and general-purpose programming language. It is designed to be simple, readable, and easy to learn. Unlike many programming languages that require complicated syntax, Python allows programmers to write programs using fewer lines of code. This makes programming faster and more enjoyable, especially for beginners. So, why actually Python is so popular? Let's look at some reasons. Python is very easy to learn as it has simple and clean syntax. Its code looks like English because beginners can focus on learning programming concepts instead of worrying about complicated syntax. Python is easy to read as it's most neat and organized. Even if someone else writes the code, it's usually understands easy to understand the Python language. This is one reason why Python is used in companies. So in many situations, Python allows us to perform the same task with fewer lines of code comparing to the other languages. Like, yeah, let's see the difference. The simple hello world example is given in this presentation slide, which clearly differentiates how a simple printing displaying hello as an output in C and displaying hello as an output in Python. Both are different. So this is one of the these less codes make faster development and fewer chance for making mistakes. Python has a large community with millions of developers around the world using Python. Whenever you face a a problem, there are tutorials, forums, documentation, and communities ready to help. This strong community supports makes learning much easier. And Python is a cross-platform program written on Windows. A program written on Windows can also run on Linux or Mac OS with very little or no modification. That makes Python highly portable. And Python is of course free to download and use. Anyone can learn it without purchasing the expensive softwares. It has helped Python become popular among students, researchers, and companies worldwide. Application of Python. Now that we know why Python is popular, let's see where it is actually used. You may be surprised to know Python is used in almost every major technological fields like web development, data science, artificial intelligence and learning, automation, and cybersecurity, and many as follows. So, can you tell me one application you use every day where Python might be used? It's correct. Whether it's AI applications, automation tools, websites, or data analysis, Python plays an important role in many modern technologies. That's why it's one of the best programming languages for beginners and professionals alike. So far, we have discussed programming concepts, algorithms, flowcharts, translators, and Python. Now, it's our final time to write our first Python program. Every programmer's journey begins with a very simple program called Hello World program. Let's open the IDLE and write our very first program together. Now comes the most exciting part of today's lecture. Until now, we have learned the theory behind programming, but programming is a practical subject. The best way to learn programming is by writing programs yourself. So, why it is called Hello World? Almost every programmer in the world starts learning a new programming language with a simple program called Hello World. You might wonder, why don't we start with the calculators or some complex programs? The answer is simple. Before solving big problems, we first need to check whether our program environment is working correctly. Hello World program is the simplest possible program. So it teaches how to write code, save a file, and execute a program successfully. That's why it has been a tradition in programming. So now I have opened Python's 3.13 software, which has inbuilt interpreter. So I have opened the script mode using Control Shift N. Okay. So if Python is installed correctly on your computer, we are ready to write our first program. So create a new file and save it with the extension .py. So I am saving with demo, and then I am saving with hello.py. The py extension tells the computer that this is a Python program. So now type the following line as exactly as shown here. Print hello world, and this is our first Python program. So let's understand each part. So the word print is built-in Python function. Its job is to display information on the screen. Whenever we want to show test numbers or results to the user, we use print function. We will use this function in almost every program throughout this course. Parentheses. Parentheses contain the information that we want to display. Python reads whatever is inside parentheses and prints it on the screen. The use of double quotes. So the word hello world are enclosed inside double quotation marks. Whenever we want to display text in Python, we write it inside the quotation marks. Python treats everything inside the quotes or text, and it's also called as string. So we'll be discussing about these kind of data types in the upcoming lectures. So now let's save the file using Control S, and then if we run through the terminal, if everything is correct, the output will be hello world. So congrats, you have just written and executed very first Python program. So let's try something interesting. Instead of hello world, let's type welcome to Python in inside the parenthesis. Welcome to Python. And when I save it and run, what output will be? Exactly. The computer will display welcome to Python. So this shows that the print function simply displays whatever the text we will place inside the quotation marks. So there are some common beginner mistakes which may occur while writing the first Python program. They often make small mistakes like forgetting the quotation marks, forgetting the closing parenthesis, typing capital P for print instead of normal print. Remember, Python is a case-sensitive language. Saving the file without .py extension. These small mistakes may produce errors, so always check your code carefully. So now I will like to everyone to make a small change. Instead of printing hello world, print your own name. For an example, my name is Rahul. Like instead of that, or like my name is Priya, etc. Like print your own name. Now I'll be printing my name here instead of welcome to Python here. And I hope all of you will try to make your name printed on the screen. My name is Bharat. So my name is Bharat. Is run. Excellent. Now you have modified your first Python program. So let's quickly revise what you learned today. Today we understood Today we have understood what programming is, what is programming processes, what is an algorithm, how flowcharts represent program logics, what pseudocode is, programming languages and their type, the difference between compiler and interpreter, why Python is one of the world's most popular programming language, application of Python, and finally we wrote and executed our first Python program using print function. So this marks the end of our introductory lecture. Don't worry if some concepts seem new today. The programming is a skill that improves with regular practice. In upcoming lectures, we will move to move from theory to the practical programming. We will start learning variables, data types, and operators, where you will begin writing more interesting Python programs. Until then, revise today's concepts, practice hello-world program a few times, then try changing the text inside print function to become familiar with Python. Thank you everyone. Have a great day, and I will see you in the next lecture.